Alright, this is the last video on solving rational equations. This is the second worksheet on this particular topic. The only way to get here is to get through solving rational equations 1 successfully. So this is some extra practice to be sure you've got it before we go into solving some different stuff. Alright, so let's just jump in. It's not that much different. It might not be different at all than what you've already done. You're still looking for common denominators. You're still trying to figure out what's missing. So in this case, let's find out. I have a 4, I have a 4, and I have a 4k. Well, obviously what's missing is I don't have a k on these two denominators. And when I put it here, I'm also going to have to put it up here. And I need to be careful how I do it. So I'm going to put these in parentheses. Now you know that when I multiply both sides by 4k, that everything goes away. That cancels my denominator. That's the whole goal of doing it. So the more complex part of this worksheet is that I'm having to distribute k out to these terms before I simplify. Alright, so k times k is k to the second power. K times 4 is 4k. K times k is k squared. K times negative 1 is negative 1k, or just negative k. I'm at my equal sign, and I have k plus 4. So now we're combining like terms. So let's combine k squared plus k squared, and that's going to give us 2k to the second power. I have 4k minus k, which is 3k, equals k plus 4. Alright, if you think way back, you had a worksheet that was called Solving Quadratic Equations. I want you to think back to that. And I think it'll look familiar once you see this. What I want to do is create a zero side. And the easiest way of doing that is to leave the positive leadoff term alone. So I'm going to subtract k from both sides. And I'm also going to subtract 4 from both sides. And here's what I'll get. I'm going to get 2k to the second plus 2k minus 4 equals 0. Now, the next thing that I want your brain to pick up on when you see these, like when you're working them, I want your brain to catch things. I have a common factor that I can pull out. Factor first. I'm going to pull out a 2, and it's going to leave me with k to the second plus k minus 2 equals 0. What happens if I divide by 2? And I'm going to have to go up here to do that. 2 divided by 2 cancels it on the left side to 1. What's 0 divided by 2? 0 divided by 2 is 0. So I'm going to work with this problem right here, k squared plus k minus 2. I'm going to factor it. And don't forget the equals 0 part. That's what's sort of new to this problem. K squared is k times k. There's only one way to get 2. That's 2 times 1. And how do I get a positive middle term? I have to have a 2k minus 1k. Now I've got two answers. And they go in these symbols separated with a comma. Now how do I solve this? It goes back to the solving quadratic equations page. If I set k plus 2 equal to 0, the way to solve that one-step equation, subtract 2 to both sides, I get k equals negative 2. That's one of my solutions, negative 2. I do the same thing here. K minus 1 equals 0. Well, if I add 1 to both sides, I get k equals 1. You know 1 minus 1 is 0. So my two answers are negative 2 and 1. You're combining several skills you picked up in the Algebra I coursework all in one problem. That's what makes this a little more thought-provoking, can be a little more challenging. Also, knowing what to do, which way you decide to start a problem, because that could vary student to student, and you could all be correct, and knowing when to stop are all challenges. When do you keep going? When do you stop? Now, let me look up here. I want to check something out real quick in this original denominator. I had a k at 4 times k. Well, if k could not be 0, if I got a solution of 0, it couldn't be 0 because of this denominator limitation. Again, I don't have a limitation or a restriction on my variable, so I don't have one to show you, but one will surely pop up soon. Now, let's move on to the next one. This problem looks complicated. It's not. It's just a little longer. That's it. So let's work out from top and bottom for a second. And let's factor first. Let's factor this, and let's factor this. A squared is a times a. I need two numbers that make 12 that are 4 apart, so I'm going to say that's 6 and 2. It needs to be negative, so that's factoring that. Right here, this is a perfect square. Two negatives make a positive. 5 and 5 make 10. So what's missing? I've got two a minus 5's in this term. I only have one in this term, so I need an extra a minus 5 here. I'm going to put that in parentheses. A minus 5 here. At that point, I can ignore my denominator. If I multiplied both sides by a minus 5 times a minus 5, all your denominators would cancel. All right, so I'm going to ignore this. I'm going to write, you know what, I don't need to ignore that. Actually, I'm going to save myself a step. I'm going to bring that back. On the left side of my equation, I've got a squared minus 4a minus 12 equals, now I'm over here, 6a minus 30 plus, I'm going to FOIL this out. I'm going to do a times a. I'm going to do a times negative 5. Then I'm going to do negative 3 times a. I'm going to do negative 3 times negative 5, which is positive 15. Because I need an equation that has a 0 side. That's what I'm looking for to solve this problem. So if I had just left it a minus 6a plus 2, I would actually have more work to do in my next step. So always be thinking ahead on that. I'm going to start out with the highest exponent term. And that's a habit I hope you picked up in one of the previous sessions. I have an a squared on both sides. Well, what happens when you subtract a squared from both sides? It's going to cancel. I'm going to have none left whatsoever. We're going to have 6a, let's see, I don't want to do this. I've got 6a minus 5a, which would just leave me with a on the right side. So what I'm going to do is going to add 4a to both sides. Now here's why I did that. It's going to go away here. 6a plus 4a is 10a. 10a minus 5a is 5a. So what I've done is I've handled this term, and this term. Now look here, by checking off, I now realize there's another negative 3a that I overlooked. So 5a minus 3a is going to leave me with 2a. So I'm in good shape. So it's easy to see the terms I have left. I have negative 12. I have negative 30. I have a positive 15. If I have my a's on the right side, I'm going to move all of these over here. And you can do that in 2 steps or 1 step. It's really no big deal. But by doing that, I need to subtract 15 from both sides. I need to add 30 to both sides. So my math problem is right here. 30 minus 15 is 15. 15 minus 12 is 3. So how do I answer this? 3 equals 2a. What times 2 gives you 3? Now don't do it the hard way. Just divide both sides by your coefficient. Those cancel and you get a equals 3 over 2. And you're finished. Right, so a lot of steps. We'll be working in this section for a little while. Number 3, what's missing? Combined with factor first. Where do you want to start? I would start right here and do k plus 1 times k as a denominator. Now I do not have right here a k plus 1. I need a k plus 1 on top and bottom here to get that to be the same. And then 5 has to be multiplied by the whole thing. So I'm going to make that 5k times k plus 1. I'm squishing that in. This was a 1, so on the left side of my equal sign, I have 1 times k plus 1. I'm just going to put the k plus 1. On the other side, I'm going to multiply this, all right? I'm going to skip rewriting this because I can read what I wrote. 5k times k is 5k to the second power. That's distributing here. 5k times 1 is just 5k. This had everything I needed. So I'm just going to put that plus 1 from my numerator on top. If I multiplied both sides of this equation by k times k plus 1, this is what I would get. So I'm going to subtract k from both sides. I'm going to subtract 1 from both sides. And what that's going to give me is 0 equals a potentially factorable trinomial. Now, since the 1's canceled, I kind of have a weird thing going on here. But I can handle that. What's in common? Remember, factor first. I could pull a k out, leaving me with 5k plus 4. I will have two answers right here from this equation. And they're going to go in these symbols. The first one simply states that k equals 0. Because I said k equals 0. Think of that in parentheses. The other one would be 5k plus 4. I need to set that equal to 0 also. Subtract 4 from both sides. I get 5k equals negative 4. Divide by 5. And I get my other answer is negative 4/5. Alright, now let me introduce restrictions on variables. I have to reject the 0. Can't equal 0. The reason why is you look right here, if I set 0, or even right here, if I set 0 in a denominator position, I would be creating an impossible math problem. You cannot divide by 0. I have to reject 0 as an answer. So actually, negative 4/5 is my only plausible answer. Remember, if you create a situation to where 0 is in a denominator position, you've actually committed like a math felony. So you can't do that, okay? So you have to be looking for that as you go. If you miss it, I won't bust your chops, but you want to be looking for that and get used to that. Okay, the last one. This looks like a sweet mess. It kind of is. I don't know how long this problem is going to actually be, and I want to keep this video short because each problem is going to have its own unique twists. Just remember, factor first. So when I'm looking at this, I'm looking at an n squared getting pulled out with n minus 2 left in parentheses. Again, n squared here with an n minus 2. It's the same thing. So what's missing? Factor first. Ask yourself, if I can spell, what's missing? And remember, your denominator is going to go away. I didn't factor this yet, so you'll want to do that. Yeah, I need both of these. I need one to be positive, one to be negative. You have to watch this problem. There's two ways of looking at it, but the signs don't always work out. So it's going to be 6 and 1. If you were thinking 2 and 3, work that out and see why that doesn't work. So factor first. Do what's missing. Create a 0 side. Find your possible solutions. Oops. And then check your denominators for a 0 problem. Alright, make sure, like in this case, if I get an answer that says n equals 0, it won't work. N cannot be 0 because you have n by itself here. And even if you put 0 in for n here, it's not going to work. And there may be another number here that will not work also. Off the top of my head, I don't think 2 would work. Because if you have an n cubed minus 2n squared and you put a 2 in there, well, a 2 minus 2 would be 0. So n cannot be 0. N can also not be 2. So if you get those as potential answers for this problem number 15, you're going to have to reject those answers entirely and see if maybe there's a third one. All right, that's as far as I'm going on 15. Again, if you have any questions, work together in study groups. Get in touch with me in class as time allows. And rewind and watch these and watch other similar videos on the same topic, including YouTube, TeacherTube, Khan Academy, even 10 Marks may have some things. All right, good luck.